Quote by Stephen Hawking, "There is no doubt that our planet Earth will one day become uninhabitable. I am convinced that humans will have to leave the solar system and travel to the stars. What will we humans do when Earth is no longer habitable?" In the distant future, NASA has an interesting answer to this question. Planets even more habitable than Earth could be the solution for humanity. The Kepler telescope has discovered over 2,000 exoplanets, but the problem is that these planets are currently inaccessible to us. However, there are some worlds in the universe so fascinating and promising that we will surely do everything possible to visit and eventually colonize these perfectly suitable super-Earths. One day all planets outside our solar system are exoplanets. Some of these worlds are different from the average exoplanets. They resemble our Earth almost perfectly or are even more suitable for life than our home. Finding these distant worlds similar to our Earth has been a masterpiece. Planets are tiny compared to their stars, and even giant stars appear as tiny, bright dots at distances of several light years. For a long time, spotting exoplanets was like searching for a needle in a haystack, but we have already overcome this obstacle. We have created a telescope that has been able to spot thousands of exoplanets in space. NASA launched the Kepler Space Telescope in 2009, and in its 9-year mission, it scanned thousands of star systems. During this mission, the telescope became increasingly proficient at detecting the transits of small planets in front of their stars. From the Kepler mission, we know of more than 5,000 exoplanets, and even after the mission ended in 2018, the search continues every day. Kepler was not alone. Today we have numerous telescopes capable of observing planetary transits and providing details on planets thousands of light years away. The JWST has been active since the summer of 2022, and this marvel of technology can detect exoplanets even more reliably and even analyze environmental data so we can know for the first time with certainty whether exoplanets host water and have an atmosphere. Our research is progressing rapidly, and we now know with certainty of more than 24 worlds more suitable for life than Earth. There are probably many more, as so far we know only a small part of the exoplanets. Webb and Kepler have discovered another 2,600 super-Earths. I bet you didn't know that the Kepler telescope has discovered hundreds of exoplanets that could be more suitable than Earth for hosting human life. However, so far we have studied in detail only a fraction of these planets. Identifying the planets is one thing. Scanning the environments and knowing the details is the other part of the search for Earth-like planets and eventually life in space. The Webb telescope easily performs this task in a few hours, but telescope observation times are limited and are also used by numerous other scientific missions. Webb is not limited to searching for and analyzing exoplanets. When Webb examines an exoplanet, we know for sure if it contains water and if it has an atmosphere. Webb can even detect so-called biomarkers in a planet's environment. These are gases and elements associated with organic life. Webb's MIRI instrument could even detect artificial light on planets and thus find clues of civilizations. Do you also find it fascinating that other civilizations might exist throughout the universe and that we have not yet managed to make contact due to the enormous distances? But if one day we succeed, or if these beings become aware of our existence, human life would be elevated to a cosmic level. For now, we are still at the beginning. But where there is a beginning, there is a road, and we humans have been following this path relentlessly for centuries. We want to know what the universe really is. We want to know how it works, and if we can travel and explore it, and naturally, we want to find out who else is out there. There might be life on these planets. Kepler 452b is one of those planets that has become the focus of humanity's search. It is a rocky planet with a solid surface that could include both continents and oceans. The planet is located 1,400 light-years away in the constellation Cygnus and has been known since July 2015. NASA scientists discovered it using the transit method when the exoplanet moved in front of the star. Kepler 452, slightly dimming it like a small dot. The star has an interesting similarity to our Sun, and the orbital period of Kepler 452b is 385 days, which is roughly equivalent to a terrestrial year. With a diameter about 1.5 times larger, it is even considered a super-Earth. These planets are usually slightly larger than Earth, slightly warmer, and orbit stars that have a lifespan slightly longer than our Sun. Astronomers call these stars K-stars, while our Sun is a G-star. Our Sun will burn out after 10 billion years, while K-stars can be active for up to 70 billion years. Researchers hypothesize that highly developed life can form better near long-lived stars because it has a longer period to develop. humans appeared on Earth, which is about 4.5 billion years old, only a million years ago. Now, with a bit of luck, we might have a few more 100,000 years where our planet offers optimal living conditions. Then things could get complicated due to climate changes. It is precisely for these future conditions that we are looking for potential alternative worlds. If we want to survive as a species in the long term, we must go into space and colonize other planets. Let's take a look at the exotic, potentially habitable worlds discovered by the Kepler mission. Kepler 1625b is a Jupiter-sized exoplanet that has a Neptune-sized moon following it. This world could be a new Earth if it is a rocky planet. So yes, theoretically, even giant planets that resemble Earth can exist in the universe. In the universe, there are planets and stars of all sizes. Rocky planets of this size would be an absolute exception, but we might never know because the universe has already surprised us with many surprises. Kepler 37b, for example, is a mini planet similar to Earth that is only the size of Earth's moon. So why shouldn't Kepler 1625b be a possible rocky world despite its size? For now, we have no certainties about this world, which is about 8,000 light-years away. We should wait for more detailed analyses. At the moment, however, the planet is not at the top of the list of worlds to be analyzed by Webb. According to scientists, there are much more promising worlds. The exoplanet Kepler 91b shockingly demonstrates that we urgently need to find other homes. This poor planet will be swallowed by its star. It is a glimpse into the future of what we can expect on Earth. Kepler 91b will be engulfed by its parent star in 55 million years because it is nearing the end of its life. The star is inexorably transforming into a red giant, and at some point it will burn its poor planet. The same scenario threatens our system. Sooner or later, we will already have problems on Earth if the sun even remotely approaches the start of its expansion. An increase of a few degrees in temperature can upset and destroy our delicate ecosystems. We can already see this effect in our greenhouse climate. This development could make Earth an uncomfortable place within a few thousand years, and even then, we as a species should see if there is an alternative somewhere. Humanity may one day find a home in the TRAPPIST-1 system. TRAPPIST-1 is extraordinarily similar to our Sun, and 6 exoplanets have been identified in its vicinity. The 5 inner planets orbit their star very quickly and complete a year in just 1047 days. Life is quite unlikely on these planets, even though TRAPPIST-1 is a bit cooler than our Sun. The radiation on these planets is probably too high for organic life. The 6th outermost planet, Kepler 11g, which takes 118 days for an orbit, remains. In 2017, a new survey of the system also revealed the presence of at least one more planet in the system. So there is more hope. It is possible that the outer planets of this system are truly Earth-like. However, the problem remains the distance of only 2,000 light-years that separates us from these worlds. Once we achieve faster-than-light speed, space will be open to us. With warp propulsion, we could visit almost all Earth-like worlds in the universe. Distance would no longer play any role in this type of transport. These thoughts are exciting, and many consider them fiction. However, many research groups around the world are working on the development of propulsion systems of the kind we know from the Starship Enterprise and other space adventures. Kepler proves that the theory of relativity is true. I bet you didn't know that it is Einstein's theory of relativity that prevents us from traveling into space. This mother theory of astrophysics states, among other things, that nothing in 4-dimensional space can travel faster than light. If we tried to accelerate mass to the speed of light, we would need so much energy to reach this speed that the necessary force would be infinite. In practical terms, this means we cannot gather the necessary energy. However, there is a loophole: interdimensional travel or space-time bending. Warp propulsion involves distorting space-time in such a way as to create a fold. The starship then slips through a dimensional fold and, strictly speaking, no longer moves within the 4-dimensional mesh of space and time. This could mean that Einstein's laws no longer apply in this case. Moreover, we still do not know if this Golden Book of Astrophysics really describes all phenomena. It was the Kepler telescope that provided further proof of the correctness of Einstein's theories. It observed for the first time a so-called Einstein ring in the universe. These are light distortions around binary stars, where one of the two creates a gravitational lens through its gravity and thus refracts light in a very specific way. In 2013, Kepler found the object KOI 256 in the constellation Cygnus, which shows exactly this effect. In this case, a small red dwarf star orbits around a 0.6 solar mass white dwarf. But let's hope Einstein was not right about everything and that we humans still have a realistic chance of one day visiting distant planets. Einstein was sure that our species will never stop learning, and that the size and changeability of the universe will always offer us further fields of research and discovery. Quote by Albert Einstein, "The most important thing is to never stop questioning and exploring." There is a good reason we are endowed with curiosity and the will to discover new things. Subscribe to the channel now and never miss a new video.